So explain why you would not expect the theoretical probability and the experimental probability of an event to always be the same. We did a little experiment in class where the results as we expected. Actually, because we did such a high number, well, considerable high number, the experimental approached the theoretical. Now, if you think about it, if you don't do a high number of experiments, so let's say you did 10 trials, you can get, let's say, tails and heads. You can get 6 tails, 4 heads. You can get 1 tail, 9 heads. Is it possible? It is, right? So you can get 2 tails, 8 heads. So not every time. I mean, our expectation is 5 and 5, but can you get 5 and 5? Yeah. Can you get 2 and 8? Can you get 1 and 9? Can you get 6 and 4? You can't. But I made a comment today that the more you do it, right, and the more trials you do it, right, the more this number over here will approach, the more the experimental will approach the theoretical, right? The more trials you do. Okay, but when it's a very small experiment, let's say 10 flips of a coin, or even 4 flips of a coin, you know, the experimental might not match the theoretical. Open-ended, 250 people are surveyed, so they wanted to create a table. So their favorite colors are, let's see, blue, yellow, green, red, and purple. All right, so it says that 2/5 of the people, decided that blue was their favorite color. So let's say 2/5 of 250, right? That means 100 people chose blue. We can say, I don't know, we can divide, we can say 25 here because we need a total of 250. We can have 30. I'm making this up, by the way. We're making 45, 45. And we can call this 50 there. There's a table. So that totals 250 and 2/5, right? 2/5 of this, selected blue. So 100 out of 250 people selected blue as their favorite color. And that simplifies to 2/5. Okay, so very silly table. You could create it. You don't have to. Oh yeah, actually, forget what I just said. All right, here is an experiment. Right. So again, the experimental probability is based on experiment. Something has to happen. You have to have an experiment with results, right? And a coin was flipped 50 times, 26 came heads and 24 came tails. Based on your results, what the probability of getting heads would be 26 out of 50. You guys feel 13 out of 25. Based on the results, how many heads would you expect to occur in 400 tries? So using this, so the probability of getting heads in the experiment was 26 out of 50, right? And if you're going to do this 400 times, right, it's going to be 26 times 8, which is going to be, we expect that if you did this, if somebody continued to doing it 400 times, 208 times would be heads based on this, right? What is the theoretical probability of getting heads? The theoretical probability of getting heads is a half, or 50%. Based on the theoretical probability, how many heads would you expect to occur in the 400 tries? So again, theoretical. If I said, hey, what's the probability of getting landing on heads on a coin, it'd be a half. So if we were to do 400 tries, we would go half times 400, and we would expect that half of the 400 tries that we would about to do would land on heads. Compare the theoretical to your experimental probability. Well, based on the experiment, right, it seems like it's landing on heads a little bit more than what we expect, which would be the theoretical. Okay. Again, simple answers. Exercise 8 and okay. What is the probability that the next car will be white? All right, so we're watching cars pass by in front of Junior High School 194. And let's see how many cars so far. 35 plus 23 plus 12 plus 20. So far out of the 90 cars that passed, right, 35 were white. So to answer the first question, 8, what's the probability that the next car will be white? Well, there you go. 35 out of 90. Or 7 in 18th chance. 7 out of 18 chance. I don't know if they didn't ask for percent or anything. But if you want to change that to percent, right, we would just go 7 divided by 18, and it would be about 38, 39%, 38.8% chance of the next car that will drive by in front of 194 would be white. Out of the 180 cars, so based on this experiment, how many would you expect to be white? Well, probability of a car being white and going by in front of the school was 35 out of 90. Now, if there were 180 cars, out of the next 180 cars that are going to drive by, how many would we expect to be white? Well, about 70. Right, that simplifies 2, and 35 times 2 is 70. 1011 used information keyboard. Cleveland made 4 typing errors in 60 words. So, what's the probability that his next word will have an error? Well, 4 out of 60, or 2 out of 30, or 1 out of 15. Right? There's a 1 out of 15 chance that his next word will have an error. In a 1,000 word essay, how many errors would you expect Cleveland to make? Well, probability of him making an error is 1 out of 15. Multiply that by 1,000. Right? How many errors will we expect? So it'd be 1 over 15 times 1,000. And it says here simplified. (62 2/3). Well, you can't make 62 2/3 error, so we'll just round that to 67. So we expect 67 mistakes, errors, in an essay that is 1,000 words, has 1,000 words. In the last 40 school days, Esteban's bus has been late 8 times. So late 8 out of 40 times. Okay. What's the experimental probability that the bus will be late tomorrow? Well, I just answered that. 8 out of 40. Let's simplify that. That would be 1 out of 5. Or as a percent, 20% chance that the bus will be late tomorrow. I think, okay, so use the survey's results to the right. What's the probability that a person's favorite snack while watching TV is corn chips? Well, the probability is 40 out of, what's the total here? 55 plus 40 plus 35 plus 50. And I said the last number was a 5. So 40 out of 150, or 4 out of 15 chance that someone's favorite snack is corn chips. Out of 450 people, how many would you expect to have corn chip as their favorite snack with television? Well, probability, and then multiply that by 450. So 4 out of 15 times 450 equals 120 people. So we can expect that out of the next 450 people, 120 will have corn chips as their favorite. What the heck is a corn chip? 15. In practice, Crystal made 80 out of 100 free throws. All right, not bad. So she's an 80 out of 100 free throws. She's an 8. So in other words, she has a 80% chance of making the 80% chance of making the free throw. So if you ever watch basketball games, anyway, whenever somebody's at the line, right? So here's the basket, right? And the guy is here, or the girl is here, and they're about to throw the basketball. Right here at the middle here of your screen, it has the player's name and then free throw percentage, and you'll see a number like that. So 80% is okay, right? It's okay. So it sort of gives you an idea of what kind of person or how skilled the person has been throughout the season. So in this case, 80 out of free throws. What's the probability that she will make the free throw? So obviously an 80% chance, which is not bad. which means she has a 20% chance of making a mistake. Next one, 16. What's the probability a team plays soccer? Well, let's see how many teams are here. So 42 plus 26 plus 24 plus 16. There's a total of 108 teams here. So what's the probability that a team plays soccer? So if I were to pick one of these kids, all their names are in the bag, and I picked a name, the probability that a team plays soccer would be 24 out of 108, which you can simplify to 2 over 9, right? Because you have a calculator, that shouldn't be a problem. So 2 out of 9. So, and we want to know out of 300 teams, if there were 300 teams, out of those, how many would we expect to play soccer? So let's assume that Miss Miller didn't want to ask the whole school, right? Because it's a little bit tedious. She asked 108 kids what your favorite sport is, or what sports you participated in, and these were results. And then, based on those results, she can apply that to 300 more kids. So out of the 300 that she still hasn't asked, how many of those should she expect to say that soccer is something that they participate in? And the answer would be 66 and 2/3. You can't have 66 and 2/3 person, so we'll write that. So 67 kids out of the next 300 should, right, prediction-wise, say that they participate in soccer. 2 coins. Toss 2 coins 50 times and record this note. Oh, jeez. Hopefully you'll skip. Well, can we do this? I'm just going to make one up. So let's say, and you can make one up too. 2 coins 50 times, and what's probably oh my god, hang on a second. You can skip this, okay? But if you want to do it, just for a little practice, you can, but you can skip this. Okay, so actually I'll make a comment very quick. 23, an inspector found that 15 out of 250 cars had a loose front door and 10 out of 500 cars had headlight problems. What's the probability that a car has both problems? Well, what's the probability that a car has a loose front door? 15 out of 250. Not right, loose front door. The chance that a car has a front door problem is 15 out of 250. And then headlight problems. What's the probability that the car has a headlight problem? It would be 10 out of 500. Okay, so this, to find the probability that a car has both problems, multiply the probability of one times the probability of the second one. So 15 out of 250 times 10 out of 500, and I didn't simplify, and hang on. I will simplify it just to make it easier. And this is 1 out of 50, so we got 3 out of 250. So the probability is 3 out of 250, and let me divide that. Well, it's a very, very small chance, 0.012 if you change that to percent. 1.2, so there's a 1.2% chance that a car has both problems. So there it is in all 3 formats. Okay. All right. Colin and Tony are playing a game where the difference of 2 rolled numbers cubes determines the outcome of each play. Okay. The graph shows the result of rolls of the number cubes so far in the game. Kyle needs a difference of 2 on her next roll to win the game. Based on past results, what's the probability that Kyle will win on her next roll? So she needs a difference of 2. Well, let's see how many times they rolled so far. Well, so far they rolled, well, let's add it up. 21 plus 35 plus 22 plus 13 plus 5 plus 4 equals. So 100 times, and a difference of 2 came out 22 times. So it was 22 over 100 And if we simplify that, right, divide top and bottom by 2, we get 11 over 50. So our multiple choice is in fraction format, so therefore I'm going to leave it in fraction format. So the probability that on her next throw, okay, let's say she rolls a 5 and a 3, that's a difference of 2, or she rolls a 6 and a 4, that's a difference of 2. So what's the probability that on her next roll over the dice that one has a number and the other has a number where the difference of both numbers is 2? Well, there's an 11 out of 50 chance of that happening, right? Because it could be 5 and 3, 6 and 4, it could be 4 and 2, it could be 3 and 1, it can be 6 and 4, we read that, 5, 4, no, that's it, right? So the answer would be B. 25, short response for each. Local video store has advertised that one out of every 4 customers will receive a free box of popcorn. Just to see how old this question is, was their video rental. Okay, so far 17 out of 75 customers have won popcorn. Compared to experimental and theoretical probability of getting popcorn. Okay, so 1 out of 4 is 25%. So the video store is saying about 25% of all their customers will win a free box of popcorn. So far, 15 out of 75. So let's change that to percent. So 15 out of 75 is 20%. Compared to experimental theoretical probability of getting popcorn, well, so far, the number of customers that have won is a little bit lower than what the local video store has advertised. Okay, so only 20% of their customers have been winning, as opposed to what they had said that 1/4 of their customers will be winning. Okay, video rental. My God, they're so lucky. There are 3 red marbles, 4 green, and 5 blue in the bag, so that gives me a total of 3, 7 plus 5, 12 marbles. So there's a total of 12. Once the marble is reselected, it is not replaced. So once you take the marble out, you select the marble, you leave it outside, and you go back in the bag. Find the probability of each outcome. So, it's probability of getting a green. Well, the probability of getting a green in the first try is 3 out of 12. You take the green, and let me put it here. You go back in the bag, and you want to select another green. Well, there's no, sorry, not 3, but 4. 4 out of 12 chance of getting a green in the first try. So you put the green on the side, you go back in the bag. Well, you'll notice that there's no 4 green marbles anymore. There's 3 green marbles, and then there's 11 total. So what's the probability of, getting 2 green marbles? Well, simplify this. You have a 1 over 11 chance of that happening. Okay. What's the probability of getting a blue and then a red? Well, the probability of getting a blue is 5 out of 12. So let's say you take the blue, put it here on the side. Go back in the bag, and you want to get a red. Well, there are 3 red marbles, but the total has changed. There's 11, right? Because 1 blue has been out. Simplify. You have a 5 out of 44 chance of accomplishing it. Okay. Food: pepperoni, mushrooms, onions, and green peppers can be added to a basic cheese pizza. How many 2-item pizzas can be prepared? So how many choices do you have for your first? Although I don't, well, how many choices do you have? We have 1, 2, 3, 4. So for your first topping, how many choices do we have? We have 4. For your second topping, how many choices do we have? We have 3 toppings, right? Because 1 has already been used. So how many different toppings can we make here? How many 2-item pizzas? 12. Although, hang on a second. I don't think it's 12. Well, we can do pepperoni and mushroom. Pepperoni and onions. Pepperonis and green peppers. Okay, and then we can do mushrooms. We can't do it pepperoni because we already used it. We can make mushrooms and onions, mushrooms and green peppers, and then onions. We can't do onions and pepperoni because we can't do onions and mushroom, but we can do onions and green pepper. And then finally, green pepper. Can we do it with pepperoni? Already done. Can we do it with mushrooms? Already done. Can we do it with onions? Already done. So actually, it's not 12. I forgot it. This is 6. 1, 2, 3, 4, 5, 6. And we'll talk about that tomorrow. All right, find 35% of 90. Well, 0.35, so on your calculator. I'm going to go 0.35 times 90. And we're going to get 31.5. That's 42% of 30. 0.42 times 340, sorry, 340. 0.42 times 340 equals 142.8. And what is 18% of 90? So again, 0.18 times 90. And we got 16.2. Okay, and I'll quickly, hopefully, go to Google Classroom and let you know that you don't have to do questions. What was it? The 2 points, 18 to 22. All right, that's it.